Great. Thanks.
Sorry. Thanks, Matthew. This might be old news in the new newspaper for a lot of you, but a lot of farmers have not yet adapted to application methodology on more modern tree structures. And this is what we've seen over the past 20 years, where through the process of modernization, our tree structures, our orchard layers have changed from more larger conventional tree structure open vase systems with larger interplanting spaces and wide row widths to more high density trellis plantings that have much smaller depth and density or higher planting densities, but in terms of depth of the canopy and height of the canopy, much smaller. But still, and I get around, a lot of production units are still using old conventional spray application methodologies that are based on old systems that was developed in the 80s and 90s on larger open vase trees with very large, with very high heights and wide widths. Around 2,000 to 3,500 TRV trees, and we're still implementing those type of application methodologies on these new high-density plantings, slow tractor speeds that are set, high air volumes with our sprayers, higher than 65,000 cubes, in relation to when these trees, which are much smaller and much less dense, with narrow widths, do they actually need all of this energy that we're putting into the application process? And secondly, what is the influence on pest and disease control, specifically in this case on pests? Are we being super optimal, or are we actually moving in the right direction by being more energy efficient, spraying lower volumes, faster tractor speeds, and lower air volumes? So in this specific study, we went out to optimize volume selection for these high density orchards. In the previous research showcase, I presented the data specifically on the optimization of the volume of spray volume and canopy adapted spraying, where the sprayers are matched specifically to the orchard in terms of speed and air volume. And in this specific study, we went out to see if we get any biological efficacy in terms of, in this case, red spider mite control. In 2021, we couldn't find any red spider mite infestation trial sites, specifically where we did the trials, on this my plaza. And in 2022, we found a trial site that had high numbers of red spider mite. It was specifically a Forel pear orchard. What we did was we did some pre-counts beforehand, before the day that we did our applications, and 6 days after that we did the spray application. And basically this was 5 leaves on the inside and 5 leaves on the outside. We on 3 data trees per replicate, and we had 3 replicates for each of the following treatments that we did that was laid out in a nonlinear fashion, specifically in the orchard. We used fenproximate or lesson as our model chemistry or miticide to do the specific trials. The specific orchard had a TRV of 2,000 and 2,057, and that should be a 4 meter row width, not a 4.5 meter row width. Our treatments that we applied, these volumes were based specifically on the optimization work that we did, was 500, 1,000, 1,500, and 2,000 liters per hectare, each with a set concentration, either 4 to 1.5 or 1x, depending on the water volume based on that specific TRV. The best speed that we found for this specific orchard was 4.2 kilometers per hour, and we used a high-profile sprayer to do this specific application. And this is what we got. The blue bars is specifically the leaf infestations that we, in our pre-counts, and they did not differ statistically between the different sections throughout the orchard. They were around an average of 4 to 7 mites per leaf. And with each of these specific applications, either if we spray 2,000, 1,500, 1,000, or 500 liters of water per hectare, we got very good control in each of those cases when the sprayer was set up correctly with these more optimal application style, and which indicates that the super optimal old conventional application systems that we're using is super optimal. You can be much more optimal, specifically in terms of application. So just in conclusion, we couldn't find any differences in terms of efficacy between the different water volumes and concentrations that we used. The red spider mite control, and you will hear this a lot in the field, that you need more water for red spider mite control, was not influenced by the water volume specifically. And you can be much more optimal by using lower volumes that fit the specific canopy that you're applying it to get commercial control specifically on your farm. Thank you very much.